Today we're going to go over the product rule and quotient rule. Before that, we're going to go over a quick thing about the constant rule, or the constant multiple rule. So the constant multiple rule, you kind of see it in the power rule. So the power rule again is y equals a times x to the n. Then you're going to have dy over d of x is your a times n times x to the n minus 1. So you kind of see this a coefficient is always there. So for example, y equals 3 times x to the 4th. We could just take out that 3 and derive the x to the 4th instead. So dy over d of x. So really just take out the constant and you're going to plug it back in later. So dy over d of x equals 3. So don't worry about it, we'll just multiply it by it later. And then we get the derivative of x to the 4th, which we know would be 3. And then 4 goes into the front, 3 times 4. X to the 4 minus 1, which is 3. And 3 times 4 is 12x to the 3rd. We might need that a little later. So then if we have a string of variables in addition, that would be the sum or difference rule. So basically if I had y equal a function f of x plus another function g of x, we just know that the derivative would easily be f prime of x, which just means the derivative of that function and the derivative of the next function. So for example, if I had y equals 3x squared plus 2x to the 5th, my derivative, my y prime, would be 3 times 2, which is 6x, plus 5 times 2, which is 10x to the 4th. Nice and simple. You do the same thing with division, subtraction. Y equals 7x to the 3rd minus 3x. Our derivative would be 7 times 3, 21x squared, minus x to the 1 would be 3. Okay. So now we're going on to the product rule. So instead of addition, if I had my function y equals f of x times g of x, your derivative would be derivative of the first function times the second plus the first function times the derivative of the second. So for example, so we can use this. This would be the product rule. And you could do that for even if you had, say, 3 functions or 4 functions, a to the x, b to the x, c of x, and d of x. Your derivative would just be the derivative of the first, multiply it by everything else, b of x times c of x times d of x, plus, and then you would multiply, keep a of x, and then you'd have the derivative of b of x times c of x and d of x, plus a would stay, b, derivative of c times d, and then last but not least a of x, b of x, c of x, and then the derivative of d of x. So this would be, if you had 3 or 4, which maybe we'll go over one. Let's start simple. Alright? So we're looking at this right here. We need an example, so we'll work with numbers. So y equals, parentheses, x to the 3rd plus 2x times 3x plus 5. So looking at that, we should define what f of x is and g of x. Go in another color. This is f of x, and this is g of x. So I'll define this down here. So f of x equals x to the third plus 2x. So then I'd say, how do I find the derivative of this, right? So we did that with the sum and difference rule, which is right here. Two functions being added. So in this f of x, there's two different variables. So f are two different things that we want to look at. So derivative, we're using the power rule, 3x squared plus 2. Okay, and then g of x would be 3x plus 5, and g prime of x would be 3. And then what I like to do, so when I first started, maybe you don't want to mess up, I'll know that y prime would be this, what I had right here, f prime of x times g of x plus f of x times g prime of x. Okay, so using that, I can just plug everything in. 3x squared plus 2 times g of x, 3x plus 5, plus x to the third plus 2x times 3. So most calculus teachers, I believe, would accept this as the answer, but we're going to expand this and show another way to solve it to double check our work. So y prime would equal 3 times 3, 9x to the third, 3 times plus 15x squared plus 6x plus 10 plus 3x to the third plus 6x. Y prime here, 9 plus 3 is 12x to the third plus 15x squared plus 12x plus 10. And that's the same answer, and we're going to show that instead of using the product rule, we're going to use the addition rule, and with that we're going to FOIL this right here. So y equals, so both ways could be long. The product rule works very well if it might have more strings. Foiling it out like 3 or 4 terms would be very tough. Y equals 3x to the fourth plus 5x to the third plus 10 plus 6x squared plus 10x. And in one straight shot, this one's a little easier. It's just a bunch of power rules. 12x to the third plus 15x squared plus 12x plus 10. And if you look at that right here, we see that they are the same, which means you could do it either way. You could use the product rule, which will be easier when you have multiples, or the sum and difference rule. That one was easy to FOIL out. So moving on to the quotient rule. Well, we can go one more example for that. We can just show y equals x to the fifth times the quantity of 2x to the fourth plus 3x to the third plus 2x squared. Go back to, we can go to blue. So we need to define our two functions. So this one is f of x. This one is g of x. We see that this x to the fifth is being multiplied by everything. So f of x is equal to x to the fifth. Then f prime of x is just the power rule. Should be 5x to the fourth. Here, you got g of x equals Just rewriting it, 2x to the 4th plus 3x to the 3rd plus 2x squared. Derivative of that, 8x to the 3rd plus 9x squared plus 4x. Rewriting what our derivative would be, derivative of the first times the second plus the first times the derivative of the second. We have it all right in front of us. So y prime is 5x to the 4th times this g of x, 2x to the 4th plus 3x to the 3rd plus 2x squared plus x to the 5th times the derivative of the second, 8x to the 3rd plus 9x squared plus 4x. And that's a good enough answer. Moving on to the quotient rule. Got a little dark here. I like using, instead of f of x and g of x, I keep that for the product rule. I will use u of x and v of x for this. And then the derivative of this is derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Let's go like that. So we can go something, we'll start with easy. So we have y equals, something maybe x plus 2 over x minus 1. Again, I wanted to find my u of x, which is just x plus 2. And yet we're going to put x plus 2 over 3x minus 1, make it a little more interesting. So my derivative here is just 1. V of x is 3x minus 1. So v prime of x is 3. So I have everything I need. Let's plug it in. So this would be 1 times 3x minus 1 minus u of x, which is x plus 2, times the derivative, which is times 3, over the bottom squared, so 3x minus 1 squared. And that would be a good enough answer. You can do one more, a little more complicated. If you have y equals 3x squared plus 4 over 2x to the 7th plus 3x. We'll there. So we know the derivative would be u prime v minus u v prime over v squared. So I need to define what u is. 3x squared plus 4. Derivative of that, 6x. Define what v is. 2x to the 7th plus 3x. V prime would be 14x to the 6th plus 3. Alright, just plug everything in again. U prime is 6x times v, 2x to the 7th plus 3x, minus u, which is 3x squared plus 4 times 14x to the 6th plus 3. That's our numerator. Going down to our denominator, the easy part. just take 2x to the 7th plus 3x and square it. And there you have it. We started off going over constant multiple rule, just taking out the number in front and putting it back in. Go the sum and difference rule, so if we have two different functions, we can just derive each one separately. The product rule, when you have two or more, you could have 1, 2, 3, 4, whatever number, you just take the derivative of the first, multiply it by everything else, and then take the derivative of the second, multiply it by everything else, and keep adding those terms. Furthermore, went to the product rule, and then we had the quotient rule. I like using the U and V formula. I like writing them out. And then I just plug it into the formula so to reduce mistakes. Thank you for your time, everyone. Hope this helped.